Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 81 to the power of x equals 27 to the power, we have 81 to the power of x minus 27 to the power of x equals 0. Now, what I'm first going to do is I'm going to change 81 to 3 to the power of 4. So I'm going to replace 81 with 3 to the power of 4. So now we have 3 to the power of 4 to the power of x minus, now I'm going to change 27 to 3 to the power of 3. So now we have 3 to the power of 3 to the power of x. And this is equal to 0. Now, if we have something in the form a to the power of m to the power of n, this is actually equal to a to the power of m times n. Meaning 3 to the power of 4 to the power of x, well, this would equal 3 to the power of 4 times x, or we could also write that as 4x. Minus, now we're going to do the same thing over here. 3 to the power of 3 to the power of x. This is the same thing as 3 to the power of 3 times x, which is simply just 3x. Now this is equal to 0. Now I'm actually going to add 3 to the power of 3x on both sides. So now we get 3 to the power of 4x. These two cancel out. Equals 3 to the power of 3x. Now, because these two bases are the same, this also means that the exponents here are the same as well. Because if we have a to the power of b equals a to the power of c, this means that b is equal to c. Meaning 4x is equal to 3x. So now if I divide by 3 on both sides, I get 4 over 3x is equal to x. Meaning the only value that would fit this would be 0. So x is equal to 0. And as you can see, if we plug 0 in for this equation, we get 81 to the power of 0 minus 27 to the power of 0 equals 0. And anything to the power of 0 is 1. So we get 1 minus 1, which does equal 0. Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 5 to the power of x is equal to 7. Now what I'm first going to do is I'm going to take the log of both sides. So now we're going to have log 5 to the power of x is equal to log 7. So now an important property of logarithms is, let's say we have log a to the power of b. The power property of logarithms states that we can actually move this exponent here, b, into the front of the log, meaning this would equal b log a. So right here we have log 5 to the power of x, and we can actually move our x here into the front of the logarithm. So now this would be equal to x times log 5. And this is equal to log 7. Now, I actually want to isolate x because that's the thing we want to find the value of. So I'm going to divide by log 5 on both sides to get rid of the log on this side and to move it to the right side. So now for our left-hand side, these two would cancel out. So we would have x is equal to log 7 is equal to 0.845 approximately. And we're dividing this by log 5, which is approximately equal to 0.699. So now the answer for this, x would approximately equal 1.209. So this is our answer.